Welcome to the Right to Reason podcast. I am your host, Robert Stanley. Get ready to nerd out. Today we're asking both a nuclear physicist and an astrophysicist about relativity, the space-time continuum, black holes, whatever the hell Wi-Fi is, and if Stephen Hawking ever peed on people. This is the Right to Reason.
It's the Right to Reason podcast.
This episode of the Right to Reason podcast is brought to you by our patrons and contributors like me. We have all recognized the value of the unrestrained marketplace of ideas and have decided to make a difference. You can make a difference too. Contribute at patreon.com/right and learn more about your right to reason at therighttoreason.com. Your activism is appreciated.
I am so excited. I've got a nuclear physicist and an astrophysicist. What a crazy pairing. This is so exciting. Dr. Ben Davis and Dr. Ethan Siegel. I'm so happy to have you both here with us today.
Yeah, I'm so curious to see if we're going to talk about anything to do with nuclear or astrophysics, or if you're just going to ask us about the flat Earth.
That's kind of the theme of the show. We keep doing flat Earth a lot. It's funny. I get emails and they'll chime in and I'll get one that says, oh my God, Robert, this flat Earth thing, or, the conspiracy theory stuff, this is great. And then I'll get another email that's like, if you continue to post this kind of bullshit, I am done with the Right to Reason podcast. I'm like, what do I do? But people have strong opinions about both.
I've got to say, if you call it the Right to Reason podcast, you've got to remember the first rule, which is you cannot reason someone out of a position that they didn't reason themselves into.
Hey,
Ooh, I like that.
I got to push back against the astrophysicist. Here it comes, Ethan. I'm going to hit you. I disagree with you, Mr. Fancy Smarty Pants.
Oh, yeah? How do you get someone to reason themselves out of a position that they didn't reason themselves into?
I immediately feel afraid. I got a problem with what you said, Ethan Siegel. But okay, how about this? Let me ask you this. What about with religion, where people that didn't reason themselves into a certain faith become atheists because they were reasoned out of it? Maybe not in science per se, but in religious context, might that not apply?
I mean, what you're basically saying is, hey, if you can teach someone to reason their way through a problem, they can reach a different conclusion. And that's absolutely right. I mean, I don't know that, sure, if you want me to start talking about religion, because why not? Let's have the astrophysicist on the show and let's make him talk about religion.
You literally just said, I bet we're not going to talk about either nuclear or astrophysics. And I'm like, so religion 101. Listen, Ben, I feel like we're ignoring you, sir. Ask Dr.
I'm
Ben.
good. I've got popcorn.
Okay, cool. Ask Dr. Ben it's a Facebook page and group. Guys, I use this all the time. I'm talking to somebody on social media and they say something that I'm like, nope, I don't think that's true. And sometimes they're right, sometimes they're wrong. But the way I find out is I do at Ask Dr. Ben. And then Dr. Ben appears within 5 minutes sometimes, but sometimes within a day or two, but whatever. But he appears pretty quickly and has an answer to your science question. Ask Dr. Ben is a great way to get your questions answered. Dr. Ben, so happy to have you here.
I'm glad to be here. Don't forget you have to draw the pentagram to get me to show up quickly.
With candles.
Oh, absolutely. Sacrifice a chicken.
Supernatural Netflix thing.
It'll be better if you fry the chicken. That'll make me come even faster.
So noted. Also, Ethan Siegel, who you've already heard from, he has a book called Treknology, where he actually answers whether or not things from Star Trek are possible. And the ones that are, he actually explains how those things could occur in the future. And the things that can't happen, one of them I think was a transporter. Is that not something we can do?
Yeah, that one, there are a total of 4 technologies that are featured in my book from Star Trek that right now with our current understanding of physics appear to be physically impossible. But that doesn't mean that down the road we won't discover some new physics that makes them possible. So in my book, Treknology, I lay out for the cases where some cases the Star Trek technology has already been surpassed by what we've achieved on Earth, mostly in the field of computation and in a few cases in the cases of medical and biological or materials advances. We're doing some incredible things with those. But in the cases where we don't think it's physically possible, general, all you have to remember is there are a lot of things 100 years ago that we would have thought are physical impossibilities that are thoroughly a part of our modern world now. Physics, science in general, it doesn't end. It's a continuous process. If we happen to discover something like a way to overcome the uncertainty inherent in quantum entanglement, or if we happen to discover a type of matter or antimatter or exotic matter that falls up instead of down in a gravitational field, all sorts of things from warp drive to artificial gravity become possible. The only one that I'd say you're unlikely to see is subspace communication, because to the best of our knowledge, subspace doesn't exist. Only the regular kind of space.
No subspace. That's depressing. Ethan Siegel also has a blog /Patreon/Twitter account called Starts with a Bang. That Starts with a Bang. Blog, Patreon, and Twitter. Guys, I am so excited to be talking to both of you today. I want to ask you about relativity, black holes. SpaceTime is the same thing? I don't know. It's weird. I just had an argument with my daughter the other day about her use on the internet. You're watching too many YouTube videos or whatever. And at some point she's like, what is Wi-Fi anyway? And I'm like, well, honey, it's clear, it's like a radio signal, but it's not. And it hit me immediately. I don't know what the fuck Wi-Fi is. So can somebody help me with that? I don't know what that, if you're listening to this right now, ask yourself, what the hell is Wi-Fi? What is it?
Well, you were doing pretty good, right? You said Wi-Fi, it's like radio waves, and then your brain broke and you immediately gave up. Now, which goes to show that your daughter has you. She's got you. She knows, I'm just going to push him past the limits of his knowledge, and then he'll get all flustered, and I'll be able to use the internet as much as I want, because he'll be freaking out going to ask experts what's Wi-Fi.
No,
in the meantime, she's watching all the YouTube videos she wants, and I hope she's like listening to all the fan theories on My Hero Academia and just having a ball like a wholesome daughter.
She's
should,
a teenager.
Or whatever.
She's hitting me with questions like this just to annoy me because she's 13 and can get away with it.
Oh, and it's wonderful. I think teenage girls can see right through to the core of your soul about what you're insecure about and just needle at it. It's a special trait that I think boys and men never get, and that girls gain in their early teen years and lose it by the time they're adults. But
it's like women can plant a bomb in your brain, right? And not necessarily like 13-year-old girls, but like you're saying, like they're learning it. They're starting to develop that skill. But a full-grown woman will drop a bomb in your brain and it won't blow up immediately. You'll be like, whatever, that didn't hurt. Stupid. And you walk away, and like 30 minutes later, you're like, I'm nothing like my father.
I know that Ben is smart enough to keep his mouth shut. Good job.
Yeah, he's not saying a word. Ben.
My wife is sitting right here on the couch beside me, so I'm not about to walk into this quagmire. She says it's a skill they hone their whole lives. That's my story, and I'm sticking to it.
Very, very wise.
So you want to know what Wi-Fi is, and you said radio waves, and I'll say that's close enough. The frequency range isn't all that important. What is important is if you think about waves in general, they encode information, right? You have different waves at different frequencies with different patterns. And it's the changes in those frequencies that are superimposed atop one another that allow you to recognize my voice, that allow you to piece together what my different sounds mean together. And you're like, oh, those are these words that make up these sentences that convey these thoughts. You and your brain, when you hear these things in your ears and they cause the hairs in your ears to vibrate in your inner ear fluid, and that signal gets sent to your brain, and your brain processes that signal, you're able to say, oh yeah, like this is what I'm doing. I'm receiving this information. I'm processing it into a form that I can understand. I'm digesting it, and then I understand. Then I know exactly how this all works. Wi-Fi is very much like that, except it's using a different set of waves. It's using light waves, right? These radio waves that you talked about, at a different frequency that it's sensitive to, and that's how it's transmitting information. This Wi-Fi signal is really just a radio frequency signal.
So how do you digitize the signal?
Wait. How do you digitize the signal?
Yeah. How do you turn that ones and zeros?
You mean how do you turn a radio wave into a signal?
Well, no, because you start with a wave, like a chunk of light. So how do you turn that into the ones and zeros that the computer uses?
I mean, presumably you do a Fourier transform and you do a frequency time domain, and that will allow you to turn that into a digital signal. I mean, that's how I would do it. I don't know that that's exactly how it's done, but I would presume that's how it would work. And I would also presume that as you become more and more sensitive to higher and higher frequencies, right, as you can say, like, oh, we're going to transmit on this 5G band instead of at this 2 gigahertz band, then what you do is you're at these higher frequencies and you can extract a higher data rate from that.
I always assumed it was a little like Morse code. You just turned it on and off. You had maybe a base carrier, but then you just turned on and off a tone like a modem.
Okay, I didn't understand any of that. Dr. Ben, start us off with relativity. You got 5 minutes. Go.
Oh, I got 5 minutes to start us off with relativity. You want to talk about special or general relativity?
Okay, here's my thing.
Right.
I kind of got the impression that Einstein was trying to say that space-time is like one word. I think of space like if I put my hand out in front of my face, like I'm doing right now. I'm stretching my hand out. My hand is moving through space. After reading a little bit of Einstein's stuff, it's almost like I'm also moving through time. And I got to be honest, I don't understand that.
Well, let's see if we can maybe do something to, oh, by the way, I've spent the last 30 years trying to understand that. So,
Fair enough.
Here's kind of how I look at it. There really is four-dimensional space, and there's one dimension that you just don't have any control over. You just happen to be crashing into it at the speed of light all the time. And if you think of it as like a vector, like a velocity, when you do certain things, you rotate that vector out of the time axis and you start to go into the spatial axis with it. Some little piece of that axis, that vector where you're crashing at the speed of light through the time axis starts to rotate out and have a component in space. Let's say X, just for the sake of argument, the X-axis. So you can do that a couple of ways. You can either gather speed up, and as you approach the speed of light, time starts to slow down for you because you're moving that vector into the X-axis, and suddenly there's not as much of it available on the time axis as there was when you were sitting still. So time slows down as you speed up. The other thing that happens is you can get near something heavy. That's general relativity. So, heavy objects warp space. And again, it moves that velocity vector where you're crashing through time at the fastest possible rate you can into a different axis. But when you rotate it that way, you suddenly can't move through time as fast as you once could. So either case, you either speed up or you accelerate in a high gravitational field. Either case, you slow down time.
I'm really trying to figure this shit out, man.
It's deep, man. It's deep stuff.
It's heavy
hard
stuff.
to do.
Don't be sad that you didn't get it. Einstein didn't get it right away either. You were like, yeah, Einstein, he was the one who discovered that space and time are linked, and you have this entity called SpaceTime. Guess what? Einstein didn't figure that out. It was Einstein's old teacher, the one who famously failed him back when he was a student, Minkowski, who figured it out a couple of years after Einstein put out special relativity.
So Einstein really failed? Was it like physics or some kind of math or something?
Yeah, I mean, Minkowski is a famous mathematical physicist. Einstein really failed. Myth. It wasn't because Einstein didn't know the stuff. It was because Einstein didn't do his homework. Einstein,
What?
Yeah, if you don't do your work, you don't do your assignment because you're off working on your own thing, you're going to fail. So, yeah, you could be an Einstein and achieve success on your own terms, but guess what? Most people who go that route, you got to do your work or you're going to fail, and that happened to Einstein too.
But you might be the smartest motherfucker around, but if you're not willing to put in the work and the time, if you don't have that ambition, if you don't have that drive, nobody's ever going to know your name.
It's something I literally tell my students almost every day. I have one tell me every day that he's, some kind of genius and he really gets this stuff, and I should just acknowledge that. And I'm like, dude, if you don't show up to class on time and you don't do your work and you don't pass the quizzes, what exactly am I supposed to be basing my grade on? Your word that you're a genius? It's not going to happen.
Ethan Siegel, what's a black hole?
Oh, that's an easy one.
Is it really? Okay.
Well,
Try me. Let's see how easy it
black
is.
holes way back a long time ago, back in the 18th century. It was a guy named John Mitchell. He was actually a religious guy, the Reverend John Mitchell. He said, hey, you know what? If you took something just like the sun, same mass, same volume, right? So we know the density of the sun, and you had just something identical to this, except it was larger, right? It occupied a larger volume. So you got more mass because you kept the density the same. Guess what? If you made the sun a few hundred times bigger than it is right now, it would be a black hole. It would be something that was so dense that the speed you'd have to travel at to escape from it would be greater than the speed of light. And nothing goes faster than the speed of light. Therefore, light itself couldn't escape. And you'd arrive at, they didn't call it a black hole at the time. That phrase didn't come around till the 20th century. But today we know that as a black hole. Newton's theory predicted it. When Einstein's theory of general relativity replaced it, the black hole was one of the very first solutions that people ever found, right? It took Einstein a decade to develop general relativity and publish it in its final correct form. It took the mathematician Karl Schwarzschild fighting, by the way, on the front lines in World War I when this happened. It took Schwarzschild about 2 months from when Einstein put forth general relativity for Karl Schwarzschild to find the solution that equates to a black hole. And by the way, just to give you an idea of how difficult general relativity is, if you have this space-time, this fabric of space-time that extends infinitely in all directions, and you have no masses in it, that's the simplest solution. That's known as the Minkowski space-time. Then you come to Karl Schwarzschild's solution, which is saying, okay, let's say we have a point mass in a spherically symmetric space-time, and it's the only mass around. That's the space-time solution for a black hole, and it has an event horizon on it of a certain radius, where if you're within that radius, your escape velocity is greater than the speed of light, and you can't escape. And everything will inevitably fall down to that central singularity once it crosses the event horizon. Outside of the event horizon, it just looks like a mass. And that's it. That solution was the second solution that they came up with in general relativity, the second exact solution. You say, okay, genius, it's over 100 years later. What happens now if you put down 2 point masses in a static space-time in general relativity? And the answer is we cannot solve that. We can only solve that numerically. And that's what you do when you're a numerical relativist who calculates what do 2 merging black holes do? What's the gravitational wave signal they generate? They don't have a solution to that problem. They only have numerical computational solutions that they can do. So general relativity is really hard, but all a black hole is it's a region of space where the matter density is so high, the amount of mass is so high in such a small volume of space that nothing can escape from inside that event horizon, not even light.
It's a star, right? A black hole is just a star.
A black hole once was a star and is no longer a star.
No, it's a star that collapsed. So, that's kind of like whenever I think of a black hole.
Let me use an example, okay? We're
angry.
Look at Robert 100 years from now. We're going to look at the atoms that were Robert 100 years from now.
Okay.
And I don't know, Robert, how do you want to be buried?
Well, I wanted to be cremated, but you can bury me for the
let's say you're cremated
analogy.
then. Okay. So we put you into an oven and we turn your body into mostly combustible materials, carbon dioxide, water, whatever it is that you turn into.
See where you're going.
And then we pulverize your bones and grind them up and, scatter them somewhere. And someone goes and takes a cup of water that has some amount of your ashes in them. And they say, hey, guess what? I'm drinking Robert. And, if you were around today knowing that was going to happen in the future, you would be like, I don't really think that's me anymore. Wouldn't you?
Yeah.
So
I don't like this. Okay, so
isn't really a star anymore.
It makes me mad because I read Stephen W. Hawking's A Brief History of Time, From the Big Bang to Black Holes, and after I finished, I literally walked into the living room where my family was watching Supernatural. Funny enough, that comes back into play. But yeah, I walk into the living room and I say, I figured it out. A black hole's just a star, guys. And they're like, whatever, did you order pizza? But that was a real moment for me. And now you're just wrecking it all, Ethan.
I am. I'm a big wrecker. Fraser Kane, who runs the website Universe Today, once called me the ultimate cosmic buzzkill. And so maybe that'll be my legacy. But also, I would encourage you to not be disappointed if you were once awed by understanding something and then your understanding of it improved so that you had a more nuanced, more comprehensive understanding of what that was. I don't think that makes things less momentous. I think that gives you the opportunity to have an additional revelatory moment like that in your life.
Angry at you. Ben Davis.
Knowledge is about refinement, you know? Yeah. I agree with that.
2 on 1, 2 against 1.
You want to hear my rant about general relativity?
Yes.
You know, the thing that just drives me crazy is all the pop science shows, every time they try to explain it, they'll put a ball on a trampoline.
Yeah, every time.
And they'll talk
or a
about
sheet. They'll like have a sheet that they're all holding together and it moves around.
I just hate that so much.
Right. That helps me understand. I like those things.
But it does. I mean, first of all, the reason the trampoline has a dent in it is because you're in a gravitational field. So you're using gravity to explain gravity. No.
Why can't you just make a 3-dimensional grid that compresses in all directions when you have a point mass? Why can't you just do that? Why isn't that as easy as having a trampoline?
Well, and I think Brian Greene, I actually saw a show that he did where he tried to do that. And it's, you know, hopefully that's coming along. You know, hopefully the graphics are getting good enough that they're starting to do some things like that, and that becomes more commonplace.
Yeah, there were a few visualizations. I've actually written about that before. So if you like, Robert and Ben, you too, I can send you a link to an explainer I did of that a few months ago.
Oh yeah, that'd be great.
You know, I really thought having 2 physicists, one nuclear, one astrophysicist, having both of them on the podcast at the same time would be a great idea, which it is. Like, this is awesome. But what actually ended up happening is I'm just the third guy in the room. This shouldn't even be there. I just sound stupid. But a part of me feels like the listener is a little bit humbled by hearing the both of you, and they're going, Robert, I'm just like you, man. I'm trying to figure this stuff out.
You know, Ben and I, like, you might look at us and be like, oh, you guys, you know so much. And the answer is, you know, the more I think I've learned, the more I realize I don't know. The more I realize there is for me to understand that's puzzling and troubling. And, you know, the more I realize where the limits of our knowledge are right now.
Well, and Robert, I want you to take heart. I don't want you to feel stupid just because Ethan and I are
This is
here.
so hilarious. You literally, no, stop. You're literally like, Robert, I don't want you to be stupid.
Just because Ethan and I are sitting here. You sound like that all the time, dude.
You asshole.
I mean, that was one step above what I thought you were going to say.
I did not expect that.
I don't want you to feel stupid just because you are stupid. Like, that's where I thought you were going with that.
You son of a bitch. Okay.
Roast the host. Roast the host. Roast the host.
Roast the. All right. Dr. Ben Davis, I want you to hear this clip from Richard Feynman being asked about magnets, and he gets pissed.
If you get hold of 2 magnets and you push them, you can feel this pushing between them. Turn it around the other way and they slam together. Now, what is it, the feeling between those 2 magnets?
What do you mean, what's the feeling between the 2 magnets?
There's something there, isn't there? I mean, the sensation is that there's something there when you push these 2 magnets together.
Listen to my question. What is the meaning when you say that there's a feeling? Of course you feel it. Now, what do you want to know?
What I want to know is what's going on between these two bits of metal.
Magnets repel each other.
And, well, then what does that mean, or why are they doing that, or how are they doing it?
You're asking.
I must say, I think that's a perfectly reasonable question.
Of course, it's a reason. It's an excellent question. Okay, but the problem that you're asking, you see, when you ask why something happens, how does a person answer why something happens? For example, Aunt Minnie is in a hospital. Why? Because she went out and she slipped on the ice and broke her hip. That satisfies people. It satisfies, but it wouldn't satisfy someone who came from another planet, knew nothing about things. First, you understand why. When you break your hip, do you go to the hospital? How do you get to the hospital when the hip was broken? Well, because her husband, seeing that she had the hip was broken, called the hospital up and sent somebody to get her. All that is understood by people. Now, when you explain a why, you have to be in some framework that you allow something to be true. Otherwise, you're perpetually asking why. Why did the husband call up the hospital? Because husband is interested in his wife's welfare. Not always. Some husbands aren't interested in their wife's welfare when they're drunk and they're angry. And so you begin to get a very interesting understanding of the world and all its complications. In order to if you try to follow anything up, you go deeper and deeper in various directions. For example, you could go, why did she slip on the ice? Well, ice is slippery. Everybody knows that, no problem. But you ask, why is ice slippery? That's kind of curious. Ice is extremely slippery. It's very interesting. You say, how does it work? You could either say, I'm satisfied that you've answered me, ice is slippery, that explains it. Or you could go on and say, why is ice slippery? And then you're involved with something, because there aren't many things as slippery as ice. It's very hard to get. Greasy stuff, but that's sort of wet and slimy. But a solid that's so slippery, because it is in the case of ice that when you stand on it, they say, momentarily the pressure melts the ice a little bit, so you got a sort of instantaneous water surface on which you're slipping. Why on ice and not on other things? Because ice expands water expands when it freezes, so the pressure tries to undo the expansion and melts it. It's capable of melting it. But other substances contract when they're freezing, and when you push them, they're just satisfied to be solid. Why does water expand when it freezes and other substances don't expand when they freeze? All right? I'm not answering your question, but I'm telling you how difficult a why question is. You have to know what it is that you're permitted to understand and allowed to be understood and known, and what it is you're not. You'll notice in this example that the more I ask why, it gets interesting after all. That's my idea, that the deeper a thing is, the more interesting it is.
Okay, Ben Davis, Feynman didn't like that question, all right? But I want to ask you, what are magnets? How does that work?
Well, okay, so, and I love Feynman, but, and you'd be hard-pressed to ever hear me say anything bad about Feynman. That said, I'm going to say something bad about Feynman. That particular answer, I was really disappointed in him, because
Really?
I think he got a little tongue-tied, and he didn't quite know what to say in response to that question. But magnetism is very interesting in a lot of ways. And all it takes is current. All it takes is moving charge to get a magnetic field. Now, for the longest time, that was the end of it. You just proposed that it was a completely different field that's created by moving charge, and we call that field magnetism, and it's different than electricity. Now, if you really want a mind blower, here's the thing about that, is that magnetism is not a real force in and of itself. It is nothing but a combination of special relativity and electrostatics. Moving charge, you know about time dilation, you know about length contraction. So if you have two different currents going through a wire and they're going in opposite direction, the current in wire 1, say, looks like it's more compressed in wire 2, and so the field becomes slightly stronger and in a different direction than it would normally be if it was just charge in a wire that wasn't moving. But it's nothing more than the effect of special relativity and static charge added together into one thing.
You know, and that's really funny that Feynman did get so tongue-tied, because it was his theory, quantum electrodynamics, that actually combined special relativity with electrostatics in a quantum mechanical way.
Wow.
His was the theory that did that made the theory of quantum electrostatics and quantum electrodynamics, like the theory of charged moving bodies, that made it relativistically invariant. Because if you do plain old quantum mechanics with the plain old Schrodinger equation, that doesn't obey special relativity. You have to go to the start of quantum field theory, which is quantum electrodynamics, which was invented by Julian Schwinger and Richard Feynman. So they won the Nobel Prize for it. So to hear Feynman get tongue-tied, you have to remember, even if Ben won't say anything bad about Feynman, I happily will, because it's important to remember that no matter who your heroes are, if you have, Richard Feynman as your hero, or Stephen Hawking as your hero, or Isaac Newton or Albert Einstein as your hero, these are all individual human beings. They are all flawed individuals who, all of them, are well known for treating people poorly, for treating women poorly in particular, for being condescending to students, to other physicists, to non-physicists, and being very willing at various points to promote their own highly speculative ideas as on par with actual proven established scientific facts. When Feynman gets tongue-tied, I understand, it's frustrating if you have something you want to say to people, you want to share with people, and you know the answer, but it isn't on the tip of your tongue, and maybe you'd have to be prepared and go look it up, and you're not ready for it. I understand getting frustration. Personally, I think that's the sort of thing where the onus is on you, the knowledgeable person, to say, you know what, I know this answer, or I knew this answer, and it's eluding me right now. Is it okay if we take a few minutes and I'll get back to you? Or I'll have to give it to you another time because I just can't remember it correctly right now. I think it's very important to be humble when you don't remember the answer. What Ben said as far as magnetism goes, that's absolutely right. It's moving charge that creates magnetism. You look at a block of iron that's magnetized and you really don't think of moving charges in there. But guess what? Atoms are made of negative charges, electrons that orbit a central positively charged nucleus. And the way those atoms have their electrons move around the atoms, around the molecules, around the collections of atoms and molecules, that's what creates magnetism. There are three types of it. There's diamagnetism, which is repulsive, paramagnetism, which is attractive, and ferromagnetism, which is enormous and swamps both the effects of diamagnetism and paramagnetism where it's present. And that's what creates most of the permanent magnets that we know about. So we do understand where magnets come from, but it's not the easiest thing to explain. And rather than try to give you an explanation that's incorrect, or rather than yelling at someone for asking a question that isn't the question you wanted them to ask, I think you should just admit that, you know what, I, a physicist who knows a whole lot, don't know everything on the tip of my tongue, and this is something that's known, but not by me well enough to give you the answer right now. I don't think it should be so hard to say that.
Well, and, even the Bible says, roughly, that we all have feet of clay and we all, fall short from time to time. And, pride got him. He was supposed to be the authority figure there. He was supposed to be the guy with all the answers, the guy that was being interviewed. And you're right. There's nothing wrong with saying, I don't know. I'll go look it up. I'll get back to you. That's a way better answer than coming up with some bullshit, which unfortunately, that's what he chose to do in that particular clip, as far as I'm concerned.
We all think we understand something, and then it turns out we didn't understand it as well as we did, or as well as we thought we did. And there's no shame in that as long as you're willing to own up to it later, as long as you're willing to own up to it. Because if you're infallible, if you're someone who cannot be wrong and cannot be challenged, then you're someone who isn't going to learn anymore with the rest of your life. And if that's the way you are, then it's my feeling that it's time to die. Because if you're not learning, if you're not open to learning, then you're not living.
Well, and we're back to refinement again, right? Every now and then I'll come across something that I thought, I had a perfect explanation for. And it's like, no, that's not quite right. Like I got into a conversation not long ago about how light bends around a corner. And, I used to just think that it was corpuscular and, so the wave nature kicked around and that's why light bent around the corner. And it's like, no, those corpuscles or those little quantum of light are too small to do that.
Wait, Ben, I'm sorry. Light bends around corners?
To some degree, but in the real world, just scattering from the air.
I thought it was like a wave or like particles like shooting straight ahead. That doesn't make sense.
See, now we're really getting into quantum physics.
Oh, God damn it. I don't know. Okay, quickly explain this, please.
Sometimes light acts like a wave and sometimes it acts like a particle. And guess what? Sometimes particles act like waves.
You guys said a lot of science stuff, but at the end of the day, here's what I took from it. Stephen Hawking is kind of like R. Kelly in a wheelchair. Am I wrong? He's out there pissing on bitches.
Stephen Hawking is not like R. Kelly in a wheelchair.
I'm trying.
That is not something I would say.
This is hard to do.
Why would you even say that?
You said that they were horrible men. You said all like the scientists were like, objectifying women.
Yeah, they did that. They did a lot of things.
They're out there Bill Cosby and people.
I mean, is that your scale, that everything is either
it's
like
good or bad?
Basically
it's
a
particle
Marvel statue
wave.
ideal of someone, or on the other end of the spectrum, R. Kelly and Bill Cosby.
That's how science works, Ethan.
There's
Welcome
no
to
in
class.
between. There's no other axis. It's just that's the spectrum. And again, you've made it a digital signal. It's binary. It's a 0 or a 1.
Right. Okay.
I thought I'd missed something there for a minute. I thought, wait, did Hawking have somebody pee on him or something?
I'm sure he peed himself a lot.
Because I didn't know. I was left out.
He probably peed on people. We've all peed on people. All right. It's a thing.
No.
Guys, this has been a lot of fun. I only have time to ask you both one more question. A nuclear physicist and an astrophysicist, but I'm going to swap it on you. All right? This is going to be a challenge, and we're going to test your merit, your intellectual weight in gold, as it were. So, Ethan Siegel, you're supposed to get an astrophysicist question, which is, how long can you survive in space without a spacesuit? And Ben Davis, you're supposed to get, what is radioactivity? Why do people get all these warts and stuff on them? They end up dying, and the TV shows that we see from radioactive stuff. I don't want to do it that way. I want to get weird. I'm going to swap it. Ethan, what is radioactivity? And then if you don't mind, Dr. Ben, follow that up with what would happen if you yourself went into space without a spacesuit. How long could you survive? Ethan, go.
Okay, you take a look inside an atom at an atomic nucleus, no matter how simple or how complex it is. It's a mix of protons and neutrons, which themselves are mixes of quarks and gluons, right? These subatomic particles bound together. Not every configuration is stable, which is to say, some configurations of these nuclei would be more stable if the nucleus spat out a particle, if it spat out a particle and changed the type of nucleus that it was. So one of the common things that nuclei can spit out is a helium nucleus, 2 protons and 2 neutrons. It spits that out. That's what's known as an alpha decay. So if you take a substance that's radioactive, that's an alpha decaying substance, your hands, that outer layer of skin cells on your body, that's sufficient to stop it. It's not going to harm you. But if you breathe it in, if you breathe in an alpha emitting source and get that in your lungs, you're going to die super fast. That's how Alexander Litvinenko was poisoned by Vladimir Putin using polonium. It's just this alpha decaying substance, got it into his body. Within days, because of the high radioactivity of it, he was dead. The other thing it can do is called a beta decay. This is the other common type of decay where you have an atomic nucleus and it emits an electron. That's really weird, right? Because nuclei are made up of protons and neutrons, but you can have a decay through all radioactive decays that change form like that. They happen through what's called the weak interaction. You have all these fundamental particles that exist. One of them is called a W boson. Another one is called a Z boson. When a particle interacts with that, you can have a weak decay, which is a radioactive decay. You emit an electron, and in order to conserve charge, that means you need an extra positive charge in the nucleus. That's how elements work their way up the periodic table if they have too many neutrons. A neutron will emit an electron, turn into a proton, and that's how you change form. So what radioactivity is, it's these 3 types of decay on average in general. Alpha decay, which your hand can stop. That outer layer of skin cells can stop an alpha decay. Beta decay, they're a little bit more powerful. These high energy electrons that come out, they actually move a significant fraction of the speed of light. Your body can stop them, but if you get too much exposure to beta decay, it can cause some damage. The last kind, the most powerful kind, is called gamma decay. This is when you get an excited nucleus that's so powerful that it's going to move down to a less excited state and emit the most powerful kind of radiation, of electromagnetic radiation possible, a gamma ray. These gamma rays can destroy you externally in very short order. If a nuclear explosion, if a fission bomb goes off and you're too close by, that gamma radiation is what's going to get you. It won't turn you into the Incredible Hulk like it did to Bruce Banner. It's more likely to turn you into Trash Can Man from The Stand, where you're just dying of radiation poisoning.
Wow.
How'd I do, Dr. Ben?
You did fairly well. I'd give you a B minus.
B minus. All right. Well, your turn. Let's hear how long you'd survive in space without a spacesuit.
Well, see, I feel like I got the easy one. I'll wait to see what my grade is, though, before I actually say that. But we used to argue this point all the time, even when I was an undergrad. And even my professors would get in it, and we'd go back and forth. And, part of the argument was when you're in the vacuum of space, your blood starts to boil. So we'd always go back and forth to say, well, it's 3 degrees Kelvin.
Wait, Dr. Ben, I'm sorry to interrupt, man. I thought you would freeze. Why would your blood boil?
I was getting to that.
Okay, sorry.
So you got two problems. You got the fact that, in the vacuum of space, your blood's gonna turn into vapor. It's well below the vapor pressure of your blood, so all oxygen's gonna come out, your blood's gonna boil, and that's a problem. But in space, it's 3 degrees Kelvin. So you're also gonna freeze to death. So we used to argue, would you blow up like a bad tire, or would you freeze to death and turn into crystal first if you were just thrown out the airlock in the spacecraft into deep space? And so we went back and forth. I mean, we used to argue about that all the time. But it turns out that solar radiation is actually quite a bit of thermal energy, even in deep space. Like if you're on the surface of the moon, the side of the moon facing the sun can get up to over 50 degrees Celsius. Well, I mean, that's hotter than South Carolina in the summer in a lot of occasions. So if you're in a solar system, if you're near a star, you're not experiencing that 3 degrees Kelvin in space. You're actually warm enough. So I'm going to say you blow up like a bad tire and eventually pop like a balloon. But if you're in deep space, if you're in the Starship Enterprise and, the Klingons take over and throw you out the airlock in interstellar space, then you're probably going to freeze. All the heat's going to drain out of your skin, and it's going to be like you're dipped in liquid nitrogen, and you're going to freeze almost instantly before you have a chance to blow up. So it all depends on where you are, whether you're near a star or far away from a star. How'd I do?
You did pretty good, which is to say you hit some of the major effects. But you got to remember, we're going after the ones that are going to hit you the fastest. Like you would have that boiling thing, except you kind of have your own pressure suit that's going to prevent that from happening. It's called your skin.
Right.
And that's actually pretty effective at keeping that. So you're not going to explode. Your blood's not going to boil. What's going to happen first, though, is your body's own circulatory system is going to mess you up. Right? Your blood doesn't know that there's no oxygen outside, right? As long as you evacuate that air from your lungs, right? As long as you breathe out, you won't have those lungs explode right away. The problem is there's no oxygen and your blood doesn't know that. It cycles past your lungs, it's ready to pick up oxygen, and there's nothing in there. So your heart keeps beating and that oxygen-deprived blood goes exactly where it wants to go, which includes your brain. And when your brain gets starved of oxygen, your body goes into shutdown after about 15 seconds. So you can get rescued, but you're going to lose consciousness real fast. And then after a minute or 3, you've got that brain death. So you've got 2 or 3 minutes if you lose consciousness after that first 15 seconds. But that's going to be the thing that does you in, probably. But don't hold your breath. If you hold your breath, you explode, and that's the worst thing you can do. So unless you're Saitama from One Punch Man, don't hold your breath.
So survival technique for anybody listening. If you're in space, you're pushed out an airlock, blow all the oxygen out of your lungs, and try to project yourself into a position of rescue within a minute and a half, or else you're going to be basically Stephen Hawking, R. Kelly, and bitches.
What a perfect way to end the show.
You can ask Dr. Ben anything at his Facebook page or group at Ask Dr. Ben. Treknology. The book is out right now answering your questions about the science of Star Trek. Starts with a Bang as a blog. You can also find it on Patreon and Twitter. Starts with a Bang. Gentlemen, thank you so much for talking to me today. I feel like I learned a lot, but I also kind of got humbled a little bit.
Well, the universe is a humbling place, and if we can make you feel humbled, imagine how it makes us feel.
And it's always a pleasure, Robert. I've enjoyed it.
Thank you to Ben and Ethan. Thank you to Dave Blair at davefreesong.com/free music. Thank you to our patrons. You too can support these conversations at patreon.com/right and learn more at therighttoreason.com. Next week, an atheist, Seamus from the Free Thought Prophet podcast, and a Christian, Daniel Goggins from soundspeech.org, are going to discuss Bible stories like the flood, Jonah and the whale, and Jesus Christ. That's next week. Between now and then, remember that you have the right to reason.
I saw a little pop-up show me that it came.
Yeah.
No, I just took a snapshot. What am I doing? I don't know what I'm doing.
Do you have the same version of Skype I do where you can
Robert,
click that
take a
open conversation button?
This isn't working. Okay, good. Hey, thank you. I mean, I really mean it. Thank you so much. This was fucking awesome.
Dude,
I'm glad it was fun.
I love you guys.
It was,
I love
it
you
was
guys.
definitely entertaining.
Yeah.
Thanks for my B-, Ben.
Dipshits that
I
think
feel like an undergrad again.
Ben gave you a B-. What grade did you give Ben?
Oh, I just told him he did a good job, and then I corrected him.
yeah.
But what grade would you give him?
What grade would I give him?
Yeah, 'cause
I'm
he
an
screwed up
easy
on
grader.
skin.
I'll give him an A-.
Aw, see,
Okay.
Ben, don't you feel like a jerk now? He gave you a better grade.
Right. See, I was hoping he'd give me a worse one and then I'd feel okay.
Yeah. Okay, we're running out of time. We're coming up at the end of the episode, and I know you guys' time is valuable. You guys. I know your time. Actually, is that my ice cream truck, or is that you guys?
It's definitely you.
Well, give me a second till it goes.
I can tell because Skype has the little white bar about you. Just go buy the damn ice cream, okay? Just go buy the damn ice cream.
That'll only make him come back. Anyway, okay.
Now I'm hungry.
Have you guys have chewed gum long enough where like your jaw starts to hurt? You know what I mean? Because the gum's hardening.
I have TMJ disorder, so yeah, I have problems with that muscle in my jaw.
That's what my brain feels like, both the jaw and the gum.
All right.
After this conversation, like I am just like.
Sounds like a good day to me.
Right there. That was great. What's my my R. Kelly thing too much? I felt like I kind of shit on like a intellectual thing, but I want to make it like funny.
Hawking would laugh if he'd heard that. It's okay.
He would be very happy to be the butt of any jokes.
Edit after that laugh. You guys are fucking crazy. All right, but no. Ben, before I get to
He's
the topic,
not even gonna put it in the show.
No, I'm gonna no, that's all gold. That's all gold.
It's his show. It's his right.
No, that's all gold. I'm gonna use all that.
Pleasure to meet you, Ben. Good to talk to you again, Robert, and thanks for having me on.
I've enjoyed it, guys.
All right, we'll talk again soon.
Y'all take care.
The Right to Reason podcast is shaken, not stirred.
You're so corny.